Hi everyone, my name is Philine and I'll be talking about person re-identification in ProCam today. And I would like to cover the following topics. So first of all, what is re-ID and why do we need person re-identification in the ProCam project? What are its main challenges? And then I'll present an approach which is called aligned re-ID. We will evaluate this approach in different scenarios. Then we will derive a conclusion from these scenarios. I'll list a few limitations of this approach. And in the end, I would like to formulate or summarize this presentation by formulating a quick takeaway message and suggesting some future work maybe. So first of all, let's just directly jump into it. What is re-ID and why do we need it for ProCam? So person re-identification is the process of associating a unique ID with an image of an input person, and to be able to assign the same ID again if the person shows up in a new image, which might come from another camera or might be taken at a different point in time, for example. And one usually solves this issue by creating a gallery of reference images and trying to match a query image to one of these gallery images. And we simply assign our query image the ID of the reference image it is closest to. So why do we need this for ProCam? Because throughout the day, you've seen ProCam involves various analysis tasks, for example, counting the number of people having fever. And simply, if we count the same person twice in such scenarios, we highly distort our statistics. And another point might be user-friendliness. So if we notify people to have fever, for example, we only want to notify them once. So, this task seems to be quite simple for us humans, but it is very challenging for the computer for multiple reasons. So first of all, before we can actually do this matching task, which I just described, we have to detect people in the images. So we need some person detector, which quite often produces faulty detection bounding boxes, as you can see in A and B. The other thing is that people might have pose misalignments, non-rigid body deformations, which vary from the reference image. Another problem or challenge is that bounding boxes overlap, so there are different identities within a bounding box. Persons might be occluded by other objects, as shown in F here, and we might just simply have similar appearances, so people looking very much alike. In our particular setup, we furthermore have the demand for real-time application at some point, and probably the most challenging thing is that we do not actually have a gallery as ground truth, but instead we need to create it on the fly, which is known as OpenSet re-ID. So most approaches trying to solve the re-ID problem are neural network-based approaches, because they are especially capable of computing and embedding of the cropped images, which separates people from each other quite well. And I particularly looked at the aligned re-ID network, which consists of a CNN network as backbone, which is ResNet 50 in this case here, which processes cropped images. They are rescaled and then normalized, and the CNN will then produce an embedding, so a description of these frames. And these descriptions are then separated into local and global features. And this is the unique part about this network, that these features are trained jointly. And the global features highly benefit from the information contained in these local features, which are information on the horizontal basis. So luckily, this network was already implemented and trained in Python, so I could directly take it and integrate it in the ProCam architecture, which I try to represent through this system architecture here. And those are the areas that I got into contact with during my mini project. Since I guess most of you who worked on ProCam as well have been in touch with camera setup and data collection, I won't go too much into, or not at all, go into detail of these two parts, but directly focus on the pipeline here at the bottom, which will have to run on some device which has GPU for fast processing. So let's start with detection and tracking. As I said before, we require some form of object detection method and then filter for the person class in order to detect people and images. And I tried two different object detection methods, which you've also seen today. And it turned out, so MobileNet SSD, sorry, and YOLO v3. And it turned out that the aligned VID network performs a lot better on the YOLO v3 object detector. And my assumption is simply that it was trained on a data set which had been processed with this object detector. Then after that, I placed the tracker for performance reasons. So object detection, although it claims to be in real time, can be, well, especially if it is done at every frame, can take up a lot of time. And if we want to do further processing in the end, this is kind of a bottleneck. So instead of running the object detector, I run a tracker here and only rerun the object detector maybe every 15th or every 30th frame. And in the other frames, we just compute the offset of the bounding boxes for efficiency. And once we have done that, so we have the cropped images or the cropped frames, we can now look at the VID part. So the VID part, as I said, has at the beginning the trained network here, which will produce these global features and local features, but we only use the global features for gallery retrieval, simply because the authors claim that they suffice for unique identification. So what we do is, because we need to create this gallery on the fly as well, for a query feature vector, which we just produced, we compute the Euclidean distance to all the available gallery vectors. Simply taking the L2 norm here, we will store the minimum distance. And if this distance is still larger than some threshold theta, we say, well, all our query feature vectors are just simply too different to the query feature vector. So this must be a new identity. Otherwise, it will be assigned the ID of the feature vector it was closest to in the gallery. So with this approach, I try to look at its limitations and see in which scenarios it would be stable, and will assign IDs well, stably. And of course, there's not a proper experiment, but I try to manipulate a few variables which are associated with the recording. So first of all, having like a different number of participants, either being 2 or 3. There's mostly, well, due to the current situation, quite a small number. Then varying the distance from the camera, being either far or close. So far, meaning about 5 meters away from the camera, close 2.50 meters to 3. Varying lighting conditions, so either as plain background as possible, so white wall, or illuminated, where people would move in front of a window. Then different actions, so being either static or dynamic. Static meaning literally not moving, well, that was intended, or dynamic, moving around, maybe also crossing each other. And then for these combinations, I determined thresholds, which I well mentioned before, the theta value, and I would, well, go and check if the outputs would be stable or not. So I would like to show you these 3 runs here. So we have two dynamic runs here, because I think they quite well represent, these 3 runs quite well represent what the approach is capable of and what it isn't. So this is the first approach, 2 participants in front of a white wall, moving around dynamically. And as you can see, well, their IDs are quite stable. It flickers at one point on the left, but it goes back to the intended ID quite quickly. What is a little bit more challenging is if people cross each other. Then we have this overlapping bounding boxes scenario, and then the IDs flicker around again. What is good here, I'll stop this for a second, is that the guy, and this is the actual re-identification which happens, the guy on the right here is assigned his original ID again, but as soon as they get close to each other and even overlap, well, the approach has difficulties. Then the approach with 3 people here on the right, you can see the 2 of us being quite stable, but the guy on the left, I will repeat it, starts swinging his arms, and this is kind of challenging for the approach for some reasons. So from these recordings, so from the other ones I also performed, which I didn't show in this presentation now, I concluded that this aligned re-ID approach is stable, well, for an arbitrary number of participants, but they have to be as close as possible to the camera, ideally a very plain white background and not too dynamic actions, because these produces these pose misalignments, which is a challenge. Here I kind of summarize the limitations that we've seen throughout the presentation. So occlusions are difficult, then illumination changes. So going from white background to in front of a window where we would have light coming from the background is challenging for the approach. Also, these non-rigid body deformations can be, in some scenarios, be challenging. And as I said before, it's very sensitive to the object detection method used. And last but not least, it's, well, setting these thresholds, well, might be tedious. So it would be nice to not have to do this. So as you can see, you get quite a number of limitations, and some of them actually correspond to the challenges which I mentioned before or in the introduction. However, I still believe that it is a, well, promising approach which can be further worked on. So my takeaway message from this mini project is for sure that re-identification is challenging, and that one could maybe improve it by taking into account a time component. So for example, well, implementing a recurrent neural network, which also keeps track of the previously assigned IDs, so that in scenarios where we have overlapping bounding boxes, we take into account previous IDs. Since we also have tracking, this might improve the detection results or the assignment results. That brings me to an end. So thank you for your attention. And if you have any questions, just let me know.